and welcome to Module 4, Part 1, Basics of Exponential Functions, brought to you by Team Glaze. After this lesson, you'll be able to really understand and use those properties of exponential functions, especially the product rule, the quotient rule, and the power rule. And then we're going to work on simplifying expressions with those properties. So let's go. All right, parts of an exponential expression. If I have 3 to the 5th power right here, what is my base and what is my power? I know that my base is the 3 and my power is the 5. But what does that mean? It means I multiply 3 by itself 5 times. 1, 2, 3, 4, 5. And I can actually get a number as well. 3 times 3 times 3 times 3 times 3. In this case, we're just going to simplify the expressions. Okay, what about x to the 4th? My base is x as marked, and my power is 4. That means I multiply x by itself 4 times. What about 0 cubed? Same thing. 0 times 0 times 0 equals 0. Okay, what are the exponents? What is the exponent here? 3. There's no written exponent. What does that mean? Okay, the implied exponent here is that 1. 3 to the 1st power is just the original number. That works for anything. So if I have x times y here, I can think of it as x to the 1st power, y to the 1st power, or I can think of it as this whole base, xy to the 1st power. Now, what about bases? What is the base here? Well, let's bring up an example. Y cubed. The base is y. Now, what if I have something a little bit more complicated? X times y cubed. The base would be the entire piece, x times y, and the whole thing is cubed. As you can see, that means that I take x times y and I multiply the whole thing out 3 times. Now, what about exponents of 0? What does that mean? Well, by definition, or graphically, you can see that any number to the 0 power always equals 1. So 5 to the 0 power equals 1. What is that? 1,000,000 to the 0 power equals 1. Negative 5 to the 0 power, does that equal negative 1? No, it equals 1, no matter what I have, except for one little exception right here. 0 to the 0 power, you don't have enough tools to understand what's happening there. So we're not going to worry about that one. Doesn't equal 0, doesn't equal 1. It's kind of its own little thing. So something to get you excited about in future math. You'll be able to figure out what that means in calculus. All right, let's look at the product rule. Write this one down. You're going to want to remember this one. The product rule says, what if I have a base to a power times the same base to another power? Product means multiplication. In this case, it means I have 3 multiplied 5 times, 1, 2, 3, 4, 5, times 3 multiplied 3 times, 1, 2, 3. That gives me how many 3s? 1, 2, 3, 4, 5, 6, 7, 8 3s. So it equals 3 to the 8th power. All right, so in general, some base to a power times some base to a power equals that base to the sum of the powers. So let's just do another example real fast. 2 cubed times 2 squared equals 2 to the 5th. I add those powers. 3 plus 2 equals 5. And I can also think I've got 3 2's in the first one, and I've got 2 more 2's. So 3 2's plus 2 2's gives me 5 2's. What about 2 cubed times 3 squared? Well, that's 2 3 times and 3 2 times. Can I combine those as a single base? And no, I can't. I can't combine them. They have to have the same base. So going back up here to our rule right here, remember that they have to have the same base. no matter what, so that I can combine those exponents. So the product rule only works for the same base. All right, quotient rule. Quotient means division, right there. So we have 5 threes, 3, 4, 5, divided by 3 threes. I'm going to write this a little bit differently so you can see exactly what's happening. So if I write my 5 threes in the numerator divided by my 3 threes in the denominator, then I can quickly see that I can divide out 1 3, 2 threes, 3 threes, and I'm left with 2 threes, which is 3 squared, or 9. I don't always have numbers, but I can simplify that one. So what did I do to those exponents? I had 5 threes initially, and I subtracted off or took away 3 of those threes, and I was left with 2 of those threes. So the quotient rule says if I have a base to a number divided by a base to a number, then I subtract those exponents. We can also see it written in fractional form. That's the way I prefer to see it, so that I can cross them off like we did in the previous example. It's much easier to see how that works. And once again, it's still the exponents subtracted from each other. So what if I had 6 squared divided by 6 cubed? Well, I take my exponents, I subtract them. Does it matter that it ends up being negative? No. And we're going to learn later on what this looks like if I don't want to have a negative exponent, just to wet your whistle a little bit. It will be the same as 1 over 6 to the first power, or 1 over 6. Once again, the quotient rule only works for the same bases. Make sure you have that down. Okay, the power rule. The power rule says I have some base to a power to a power. So that looks like this. Since the whole thing is squared, I take my first piece and I multiply it by my second piece, so I have 2 of them. And now I look at all of those x's. I have 4 x's times 4 more x's. How many x's do I have all together? 1, 2, 3, 4, 5, 6, 7, 8. I have x to the 8 x's, or 4 times 2 x's. So what happened there? It looks like I took my 2 exponents and I multiplied them together. And that indeed is our product rule. So write that one down. Any base to a power is that base to the multiplication of those powers. Let's do another example. Y to the 5th to the negative 2 power. It doesn't matter if they're positive or negative. It's the same as y to the 5 times negative 2. I multiply those together and I get that negative 10. Final answer, y to the negative 10. Okay, let's simplify some expressions now. I have this base. This base is 3a. It's no longer just one thing. We talked about that. That means I have 3a multiplied 4 times. If I'm asked to simplify expressions, that means I need to group like terms. So I'm going to take them out of the parentheses. Everything's multiplied. I can use the commutative property and put all of my 3's together. And then I can group all of my a's together, which gives me 3 to the 4th times a to the 4th, which is 81a to the 4th. Now remember, if I have numbers, I'm going to start to multiply them now. 3 times 3 is 9. Another 3 times 3 is 9. I can multiply my 9's together and I get my 81. Okay, so there's my number part. And the a to the 4th, since I don't have anything to plug in, it just stays a to the 4th. Here's another expression, negative 2 to the 5th. That means I have, what's my base? Negative 2 to the 5th power. So I have negative 2 multiplied 1, 2, 3, 4, 5 times. And now how did I get a negative out front like that? What happened? Well, I'm going to look at each piece. Remember, I can pull out a negative 1 from each piece. So let's write those all down. Okay, I have 1, 2, 3, 4, 5 negative 1s. negative 1 to the 5th power is negative 1. Negative 1 times negative 1 is positive 1. And then if I take 1 times another negative 1, I get a negative 1. I keep doing that until I realize that any odd power here gives me a negative 1 back. So that's where the negative comes from over here. And then I'm left with 1, 2, 3, 4, 5 2's, and that's where I get my 2 to the 5th. So just to see it a little bit more clearly, we have a negative 2 to the 5th equals a negative 2 to the 5th. And I can simplify that to negative 32. Let me erase some of those marks for you so you can see that a little bit more clearly. Because I can multiply those through. All right, now let's go to another example. Negative 2 squared times negative 3 squared. I don't have the same bases. I can't use the product rule, but I can write them out. Negative 2 squared, that's just 4. Negative 3 cubed, just do it in your head or write it out. Negative 3 times negative 3, let's write it out. Negative 3 times negative 3 is 9. And if I'm going to multiply by one more negative 3 times 9 is a negative 27. Now 4 times a negative 27 is a negative 108. I was able to simplify that expression. All right, here's another one. This one is not just numbers this time. We have some numbers and some variables. Okay, let's work on it. 3 squared is 9. That's where this 9 came from. Where did this negative 8 come from? Notice I grouped all of my numbers together. It's commutative. Multiplication is commutative, which means I can commute or I can move those numbers from one location to another if it's multiplied together. So I know that negative 2 cubed right here equals negative 8. Now let's look at our x's. I have an x to the 7th power and I have an x to the 3rd power. Using the product rule, I can add those exponents right there. Now let's look at our y's. Y cubed and y cubed. Product rule once again gives me y to the 3 plus 3. So simplified, I get 9 times negative 8 is negative 72. X to the 7 plus 3 is x to the 10th and y to the 6th. And moving on, let's simplify this expression. How do we do that? We've got 4ab cubed to the 3rd power multiplied by this other piece. Now remember, that power rule says that we can take this whole base, 4ab cubed, and multiply it by itself 3 times. That's the same as taking each piece and raising it to the 3rd power. So that becomes 4 cubed. That becomes a cubed. And this becomes b cubed cubed. So we have our 4 cubed, a cubed, b cubed cubed times the other piece. Now let's bring it all together. 4 cubed, I have my a cubed. I'm moving my a squared next to my a's. I have my b cubed cubed. I moved my b to the 4th and my c cubed. Now 4 to the cubed, 4 to the 3rd power, is 64. I use that product rule to add my exponents for a and b, and there's c, my final answer, 64, a to the 5th, b to the 13th, c cubed. Right, common misconceptions. How many of you think this is true? A plus y cubed equals a cubed plus y cubed. Guess what? We're going to find out if that's true or not. Let's use numbers as examples. Let's do x equals 1, y equals 2. All right, so does it equal 1 cubed plus 2 cubed? Let's find out. 1 cubed is 1, 2 cubed is 8. Add them together, I get 9. Now let's do it the other way. The other way says, let's add these. I get 3. 3 cubed is 27. These are not the same. Now, I want you to put a big X right here on your paper. These two are not the same. Okay, let's find the rule. Remember, this is a base. X plus y is a base. That base is multiplied by itself 3 times. And there's no way that can equal what we have up there. So don't ever, 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 ever do that. That's your big warning for today. All right, you should have enough tools to complete your assignment.